Hey guys, another chapter 4 video here. Topic is 4.3 if you're following along in our book in class. And we're going to talk about parallel and perpendicular lines. So, essential question today is, how can I determine if lines are parallel or perpendicular? And we've talked in class a little bit about this probably, but we're going to get into the details today. So this is a little bit where geometry and algebra start bridging together. And parallel and perpendicular lines are pretty straightforward, no pun intended there. But here's a line that I'm drawing, and I'm going to draw a parallel line right next to it. Basically, the concept of a parallel line is it's two lines that are never going to cross. They're never going to intersect each other. A perpendicular line is kind of the opposite of that. It is going to cross through the other line, but it's going to cross through at an exact angle. If I was to measure that angle that I just kind of highlighted with that arrow, it measures at an exact 90-degree angle if I was to take my protractor and measure it. So perpendicular lines are lines that cross, but not only just cross, it has to be at that exact 90-degree angle. Because lines can cross all the time, but if it's not at a 90-degree angle, then it's not perpendicular. Now, something we like to do in geometry is sometimes we label our lines, and instead of using like the equation, we might just use a letter. So I might say like this first line I drew is line L, line M, and that last line is line N, L-M-N. And I used a cursive L, if you're not very familiar with cursive. I just did that because it's really common in geometry books to do that, but you could use a regular L also. It doesn't have to be cursive. Here's what we're going to do with this picture. So we have two parallel lines and we have a perpendicular line. We're going to make a T-chart underneath of parallel versus perpendicular, and I'm going to make a nice little T-chart under that. So in this T-chart, what we're going to do is we're going to go through some basics of what's a parallel line versus a perpendicular line. And I want to start with notation first. Notation means when you're writing your notes, how do you write it? What does it look like? So for parallel lines, one of the symbols we use is we just draw these two little lines that look parallel. And since in our picture, line L and line M are parallel, I'm going to say L is parallel to M. Now when you read it out loud, this is how it reads. It's L is parallel to M. But the shorthand notation is just to use those double lines. It's a shortcut so you don't have to write the whole word parallel. Kind of a big word after a while to write. If something's perpendicular, here's the symbol that we use for perpendicular lines. It looks like an upside down T with a little box in the corner. And that symbol means perpendicular. And in our picture, we have line L is perpendicular to line N. So L is perpendicular to N, and when you read it out loud, that's how you say it. L is perpendicular to N. So there's a little notation for you. Let's slide this up and make some space. Let's talk about the definition of parallel and perpendicular lines. So we know parallel lines never cross. They never intersect. So to begin our definition, I'm going to say two lines that never intersect. But I'm going to put a big and on here, because the algebra part of this has to do with the slopes of those lines. If two lines never intersect, then they have the same slope. That is super important for you to recognize. They have the same slope. Parallel lines are two lines that never intersect and have the same slope. Perpendicular lines are two lines that do intersect, but at exactly 90 degrees. That's so important because if they intersect at any other angle, then they're not perpendicular. And here's the interesting thing, their slopes are opposites, and we're going to get into that here in a minute, but their slopes are opposites. Okay, so parallel lines have the same slope. Perpendicular lines have opposite slope. Let's look at some examples. So I'm going to give you an example of parallel lines. Let's say I had the line y equals 2x plus 7. Well, what do I know about it? Well, I know it has a slope of 2 and a y-intercept of 7. But 2 is the important number. Parallel lines have the same slope, so if I needed another line parallel, it would have to be another y equals 2x line. But instead of 2x plus 7, I'm going to change it to 2x plus 9. I could have done 2x plus 10 plus 11. I could have done 2x minus 7. As long as the slopes match up, the 2 and the 2 are the same. Same slopes are parallel lines. Here's an example of perpendicular. Let's say I had a line that was y equals 2/5 x plus 3. Now my slope of my line is 2/5. Perpendicular lines have opposite slope. So 2/5, the opposite, would be to flip it to 5/2. But I also got to change the sign. If it's a positive slope, my perpendicular line has to have a negative slope. So it'd have to be y equals negative 5/2 x. And then it could be plus 3 or plus 10 or plus whatever. But that opposite slope, that's what I'm looking for. So let's get into that a little bit more, like what's going on with opposite slope. So for our main idea here, I'm going to write, what is opposite slope? What does that mean? Well, in math, we often use the word reciprocal. Reciprocal is another way of saying the opposite slope. And by definition, it's the negative inverse of a number. So we're finding the inverse and we're changing the sign, the negative inverse of a number. I'm going to give you some examples. If I had a line with a slope of 2/3 and I said find the reciprocal, find the opposite slope. Opposite slope of 2/3 would be to flip it and say 3/2. But I would also have to change it to a negative. So it'd be the negative 3/2. That would be opposite slope or reciprocal slope. I'll give you another example. What if I had a slope of -4 and I wanted the opposite? Well, now it's going to be a positive. Instead of a negative, it's going to switch back to a positive. But I got to flip the 4. So instead, it's going to be positive 1/4. 1/4 is the opposite of -4. That's the reciprocal slope. One more example. Let's say I had a slope of -1/2. Well, the reciprocal of -1/2 would be to flip it and make it positive. So it'd be positive 2/1. But remember, 2/1 is just 2 divided by 1, so it's really just 2. So the reciprocal slope would be 2. Okay, so you probably get the hang of how to find reciprocal slopes. Let's try a problem now and see if you can do this. So here's our example that we're going to do for our notes. Find a line that is perpendicular to y equals 2/5 x plus 1 and passing through 4, -2. So we're going to find a line that is perpendicular to this and passing through 4, -2 on the graph. Well, here's what we know. If we're finding a line, we're going to find y equals mx plus b. We also know how to find the m, the slope, pretty quickly because it's a perpendicular line. If it's perpendicular, we know opposite slope. So what's the opposite of 2/5? Well, flip it over, it'd be -5/2. So we kind of have part of the puzzle put together here. We know it's a -5/2 slope. But the part that we don't know is we don't know what b is equal to. We don't know the y-intercept. So we're going to have to do some work to figure that out. So I'm going to use my point. If it's passing through 4, -2, then that's my x and y value that I'm going to use. So here's what we're going to do. We know it's a y equals -5/2 x slope plus b. We're going to change the x into the point that it's passing through, so we're going to make it 4. We're going to change the y into the point that it's passing through, which is -2. And then we're going to solve for the b. So it's going to be -2 equals -5/2 times 4 plus b. And then we'll put our line down the middle and do our algebra and get that value for b. Now, I'm going to do some math here real fast. -5/2 times 4. Well, I know 5 times 4 is 20, so it's like -20/2. But what's 20 divided by 2? 10. So really, I'm going to change that to -10. So I have -2 equals -10 plus b. Now I'm practically done. Let's make some space here so we can see what we're doing. So I'm going to add that 10 over to the other side. I'm going to get b equals -2 plus 10, which is 8. And there's our b value. So now we know what b is. We know b is equal to 8. So I'm going to put right here where the b value is, an 8. So our perpendicular line is y equals -5/2 x plus 8. There's our solution. Now let's go back to the beginning of this problem. This was the problem that we started with. We were supposed to find a perpendicular line. Well, we did. We got our answer. I'm going to put it down. Y equals -5/2 x plus 8. But these two lines that I'm going to put in a box are supposed to be perpendicular. And if I stopped right here, I'm pretty sure I have the right answer. I'd be graded at like a level 3 proficiency. Like, I've shown all my algebra, I've found the line, I've done my math, but how could I bump this up to a level 4? How could I make this advanced? I could prove it. I could graph it. Grab a ruler and set up a graph in your notes. Let's prove that our answer is correct. Pause the video so you have time to set up a nice XY axis because you're going to want it neat and nice. And I made it pretty big because I know I got to get up to that y-intercept of +8. Okay, so we're going to graph both these lines, and hopefully you have a nice graph set up. I'm going to start with the y equals 2/5 x plus 1. So I'm going to go to 1 and put my point. 2/5 is the slope, so I'm going to be going up 2/5 for my next point. And now I've got 2 points. That's probably enough for me to grab my ruler and draw my line. There's my line. And now I'm going to graph the other line, which starts at +8, so it starts way up high at 8. Has a slope of -5/2, so I got to count down 5/2 to put that point. I think I'm going to do that again. I'm going to go down 5/2 and place a point. And then I'll line these 3 points up with my ruler, connect them nice and neat, and I'll have my second line. Look at that. They look perpendicular, just like we were hoping for. They cross through each other. So a couple things I can do. I can label by the arrow the rules. I'll put the equations by both those arrows. And I'm going to label that they should be crossing at a 90-degree angle. So from here to here in that corner, I'm going to label it as 90 degrees. Now I got my perpendicular lines. And I've got my level 4. This is my advanced work. I did my algebra and I found my equation and I graphed it to prove it. So I have all the details that I need. Okay guys, so let's wrap this up. Just a quick summary here. You should have a nice T-chart in your notes of parallel versus perpendicular. We've got the notation, we've got the definition, we've got some examples. We talked about perpendiculars having opposite slope, which we call reciprocal slope. A lot of language in there, but hopefully you're able to follow all that, and we are going to practice a lot in class. Thanks guys. Have a good day.